Greetings and welcome, internet friends. Mr. Waddy and his algebra amigos here. I usually say algebra-buddies, but I figured I'd try something new. Here we go. This is some questions from a Big Ideas assignment about a pig that built himself a home. We're talking about solving systems by substitution. Step one is solve one of the equations for one of its variables. I don't want to start moving things until I know why I'm doing it. I agree with my students in the live studio audience that solving for the second equation's x is an excellent choice. The reason it's so great is because it has no numbers in front of it. So step one, I'm going to have x plus 10, write that a little larger here, equals 11. Solve for x. Wait a minute, there's not even a y in this equation. X equals 1. Actually, guys, that's like half my answer. It's like I'm partway done this already. This is crazy sauce. So, step 2, Maggie, I'm going to substitute what I just found into the t'other equation for x. Okay, so you used process of elimination. A student just said there's only one answer with a positive 1. So you are correct. You could answer the riddle, but maybe you still need some practice on the substitution technique. So maybe not. So I'm going to plug in 1 there and solve for the remaining variable. This problem is actually going to break down a little bit faster than sometimes our other ones do, and that's okay. So let's solve this for y. I did 13 times 1. I'm going to sub 13, sub 13. Guys, the most frequent mistakes that I've been observing among you is seeing you guys just make arithmetic errors. So, Avery, be careful with adding 2 negatives, for instance, or things like that. Use a calculator on the mini quiz today. Really, it's not a bad idea. This is becoming more negative, and then to solve for y, it's not being subtracted by 6, Jed. It's being multiplied by -6. And the inverse operation would be to divide both sides by -6. Josh, you don't need your Chromebook. This assignment wasn't done online. So you can follow along with me. I haven't posted this video yet, and I'm not live streaming either. So I know you're not watching it with like a 10-second delay. That would be pretty interesting, though. I get y equals 3. That's what my man Avery was just saying. And I agree, so it looks like 1 comma trace is the answer to this problem. Remember, graphically, what does this represent? It is the intersection between the 2 lines that are represented by those equations. All right. So, let me run down the steps before I slide to the next problem. Step 1, solve one of the equations for one of its variables. Step 2, substitute whatever expression you get for that variable into the other equation and solve. In this case, I didn't have a step 3 because step 1 became kind of the end of step 2. But at the end of step 2, Avery, normally I would still have a little bit of work to calculate and I'd plug it back in, perhaps not unlike what I'm going to have in this question here. All right, so for question L, where is the weak spot? The second equation's y is the preferable variable to solve for. Every other variable would create nasty fractions. Other than actually this x, I'd still have a positive 1/2 y. I almost would have gotten away with it if it wasn't for you meddling kids. So 2x minus y equals 6. I'm solving for that y. I saw someone actually just doing this problem pretty well. I liked it. Subtract 2x. I get the opposite of y. Also, sometimes back in your chapter 1 days, I would see a lot of you suddenly go from an opposite of y to a positive y. It's still opposite. You can stop clicking, thanks. Negative 2x plus 6 is what I get. So that is not what y is equal to. That's what the opposite of y is equal to. Here, Adriana, you can close your Chromebook. This was not online. So I'm going to solve for y. You could argue I'm multiplying both sides by -1. I'm dividing both sides by -1. I don't even think that much, which you've noticed. I'm just going to opposite everybody. Opposite day. Bam. So opposite everybody. Here is the end of step 1. Now I've solved for regular y. If y is truly equal to that, I can Indiana Jones substitute/swap this anytime I want. Here, Adriana, you can bring your phone up front again for the block, maybe longer. So I'm going to plug this in, and I'm going to get the following. 7x minus 3 parentheses equals 17. And in place of y, I now have 2x minus 6. Right? And this equation, I agree with all of you, and the number of likes this video is currently getting, that this equation in step 2 is worse or uglier than the equations in step, right, at the beginning. Right? There's a whole lot more going on, except it has a benefit. What is the benefit? Why is this equation easier to solve than either of these top two? I can combine like terms, and those are like terms because they have the same variable. Notice there's only one kind of variable in this equation. Here I had two variables within an equation, and if I wanted to solve for those, I wouldn't have ended up getting it equal to a number. It would have been equal to an expression. All right. Oh, super common mistake when distributing this. Careful. Make sure that minus sign goes to both of them. Yeah. All right. So 7x minus 6x plus 18, because that double neg, equals 17. Man, seriously, go check out my my friend's YouTube page, Avery Math. He also has some excellent videos on solving by substitution. 7x minus 6x is 1x. Man, seriously, we got to get this man behind the mic. He said subtract 18 from both sides, and we get x equals negative 1. Are we done the problem? I'm done solving for x, but step 3, if this is x, I could technically plug it in here or here, but the best place is there. I knew. I could tell. Everyone who said there knew what there they were talking about. This one, right? The end of step 1 is way better to plug that in for, because this equation's already solved for my other variable. Yesterday, when we did our class activity, the gallery walk, a lot of us weren't drawing these little arrows, but I really recommend it. Maybe even using multiple colors, because it would be sometimes hard to follow what step you're on or things like that, or where a particular equation is coming from. So I'm going to have y equals 2 times something minus 6, and that something is one thing, negative one thing, right there. And I get y equals negative 2 minus 6, y equals negative 8. Oop, ugh, man. Negative 1 comma negative 8. It's pigs. Pigs. I don't know. All right, so here, let me zoom out a little bit. What? There we go. I just broke the fourth wall here. You see the universe like slowly tear as I zoom out beyond the margins of my background. So guys, this problem has probably like between 12 and 16 steps of algebra to it. That's a lot. A lot. Also true, but I did provide you with the carcasses of many trees to write on if you wanted. I have piles of them. Okay. But they gave their lives so you could learn math, and that you could then save more trees in the future. So they told me it. They told me it. All right. Whoa, man, I just zoomed way out. Okay, last problem. A physical education instructor asked each student to do a total of 36 push-ups.
24? 36.
All right, pull-ups and push-ups in 1 minute. The instructor wanted students to do 8 times as many push-ups as pull-ups. Write a system of linear equations that represents this situation. How many pull-ups and push-ups were required in 1 minute? What are my variables? No. Remember, my variables are usually the question being asked. So I'm going to say x is it's a how many, not a how many calories are burned, not a how high are you pulling up or pushing up, right? Not how much do you weigh after these push-ups. It is how many pull-ups. So I'm going to say number of pull-ups. And y is the number of push-ups. And technically, it's in 1 minute, but I don't really care. All right, so let's write our equations. Someone identify a fact that you want me to underline, and in an equation, you could translate that to. Owen, yeah. All right, a total of 36 pull-ups. And push-ups. Perfect, yeah, in 1 minute. So how could I translate that, do you think? Into an equation? Or someone else, or... No? All right. But I agree, that's a fact. Now, total makes me think about what mathematical operation? Addition. And if this is the number of pull-ups, and this is the number of push-ups, if I'm adding these two things, that should be the total, right? So x plus y equals 36 seems to be my first equation. Let's figure out my second fact. It says the instructor wanted students to do 8 times as many push-ups as pull-ups. So the number of push-ups, okay, that's y, is equal to 8 times as many pull-ups, 8x. Now, a lot of times, students will write 8y equals x, but if I wrote it that way, the number that would have been larger would have been the wrong thing, okay? Here, which number is bigger, y or x? And this is why it's so tricky. They're equal when I multiply x by 8, meaning x must have been smaller, right? X would be smaller if I have to 8 times it just to get it to equal y. Is that the correct interpretation here? There should be 8 times as many push-ups, right, compared to pull-ups. Yes. So whenever they have this type of equation, go back and like rethink it just to make sure it makes sense in the context of the problem. Think about which of these numbers is going to be larger, and is that the correct setup that they wanted? All right, so most of the time, our natural tendency is to write that in the opposite way, where I would have said 8y equals x, and that wouldn't have worked out. For sake of time, I'm not going to finish solving this. The setup's enough, and we've got a mini quiz to get started. So thanks for watching, internet friends. And everyone give a good shout out to Hey Ode. At Ode, Hey Ode. Bye-bye.